Right then, so it's 2 o'clock. Let's get stuck in. So again, thanks everybody for joining me today. This webinar going to be covering the Rittal Therm software, which, as you can see, correct climate control at your fingertips. It's a really sort of powerful tool in quite a simple form, which is nice. So you can dive on there, as you'll see. We're going to run through a few live examples. You can dive on there, put in quite a small bit of information, and get out the right type of climate control you need for your installation, which, if you've seen any of my other webinars or any posts or information I've done in the past, I always push how important climate control is, because you guys, whether you're a panel builder, whether you're an end user, an engineer, whatever you are, you guys care more about the equipment, the PLCs, the drives that are inside your enclosure. Totally understand that, but for that to run correctly, it needs to be cooled and be in a protective environment, and that's where climate control comes into it. Okay, so brief introduction, put a face to the name. My name is Carl Lysett. I'm the Climate Control Product Manager for Rittal UK, and I started with the business in November 2017, so I've been here a fair while now. Past lives included being a mechanical design engineer in both the oil and gas and electrical life safety sectors. And then while I was in that electrical life safety sector, I became a product manager and thought, oh, this is quite fun. Carried on doing that, and then obviously started with Rittal. I look after all aspects of climate control for Rittal, so that's industrial and the IT portfolio, as we have two sides of that coin, because the needs are different depending on where we're going to put the equipment and what type of equipment we're going to use. I'll put this information up at the end, but if anybody wants any advice on a project, or has, wants to have a chat in a bit more detail, etc., just drop me a line at klysett@rittal.co.uk, and we can happily chew the fat on your project and get into it in a bit more detail. Okay, so that is it for my slides. So now what we are going to do is go on to the web browser. I'll just let my computer catch up here. So what we're going to do now is we're going to find where we can access the Therm software. So the first place you need to go is to the Rittal website. So rittal.co.uk. When that loads up, you get this front page. Now then, this front page has many sections along the top, obviously products, company, etc., etc. Where you want to be going for the Therm software is the support section. So if you click the drop down for support, and then you go to software, down to planning software, give that guy a click. And then we have the Therm software here. So click into Therm. Now you've got two choices dependent just personally on your preference. Okay, you've got two versions of Therm that you can download in this download section at the top right. You've got the full version online or the full version offline. Now, the only difference between those two is the online version is in your browser. So you have to be connected to the internet to use it. And the bottom one, the offline version, that sort of downloads to your toolbar at the bottom and is like a piece of software. They both do the same thing. It's just truly your preference. So I will go to the online version. Excuse me, it's taking a little bit longer than usual for it to boot up today, typically, while I'm showing you. Here we go. Right, so the first scene, the first screen we come to is, which is where we select our language. Obviously, well, not obviously, but we went through .co.uk, so it's defaulted as English, and there's a drop down of many other languages there. And what you have to do is the first time you use it is register, and just create a password and your email address. Obviously, I've already got mine, so I will put mine in there. So that's my. So just log in. Again, I apologise. It's running quite slow. It's not the software, because it's based on the speed of my internet, which is normally pretty fast, but as you can imagine, is running a bit slow today typically. Right, just bear with me a second. I seem to be having some issues. Just let me just take the screen away, and I'll come back in a second. Like I said, just apologies about this. Right, so okay, so apologies for that. Right, we're in now. So I've logged in. Totally blame my internet provider. I'll be giving them a strongly worded letter. Don't know what's happened. Everybody's obviously streaming Netflix today and slowing me down. Right, okay, so we're into Therm now, and this is the first screen that you will come to. Now, what we're going to do is we're going to create a brand new Therm calculation. So we start with this button here, Calculate Enclosure Climate Control. So we give that one a click, and then it takes us through to this next tab, which is New Calculation. If you've done any previous calculations, they would be under the Edit Existing Project section. But we're going to do a brand new one. So we'll click Create New Project, and it takes us through to the next screen. Okay, so on this next screen, this is where we need to put our main data for the project, the identifying data. So we'll start with the project name. So we'll just call it Assembly Line 1. Company can be ABC Manufacturing. Contact person, Joe Blogs. And then the originator would be the person who has created the Therm calc. So that would be me. That's obviously in there because I use that on all of my Therm calculations. You can put a telephone or a fax number in there if you're still rocking that sort of technology. That's up to you. The date is obviously automatically put as today's date. And you can click Save Project here if you wish. However, what I will tell you is, as you proceed through this, it's all auto-saving in the background. So it's up to you. But yeah, you can click Save Project if you feel the need, if that makes you feel better. Okay, so we've got main identifying details for the project. The next thing that's important and probably defines what we're going to do for the rest of it is these parameters at the bottom. Now, these parameters will stay there as we move through the different tabs. So the first one is maximum external temperature. So this is the ambient temperature in the factory, wherever this enclosure and your equipment is going to live and operate. Okay, that's the highest temperature it will see at any time in the year. So you need to think worst case scenario, not in winter. You need to be thinking middle of summer, all the machines running, it's getting really warm in there. What's the worst that could happen, basically, is the question you're going to ask yourself, because that's what we need to prepare for. So I've spoke with Joe Bloggs earlier today, and he's told me that it's a very new factory. They've got HVAC in there, and the ambient temperature isn't going to go above 25 degrees C. So you can type it in there like I just did, or you can use these buttons. Up and down buttons take it up by a degree increment, and the left and right buttons take it up or down by 5-degree increments. But again, you can just quickly click in there and type it in if you fancy. Next one is your maximum internal temperature. So this one is the temperature inside of your enclosure, how hot you are happy for it to get for your equipment. Now, if anybody saw my previous webinar, the sort of magic number that is used within the cooling industry based on the regulations that we test all of our equipment to, it is 35 degrees Celsius. The reason for that is it's the best balance between not cooling it too much and wasting too much energy, but also not allowing it to get too hot that it's going to cause damage or performance issues to the equipment inside. So it's default as 35 when you come in the Therm software. You can change that if you want. You can make it warmer, you can make it colder. That's totally up to you. But we will leave it at 35 for this example. Right, next thing is the electrical supplies that we will have to work with on site. And this is quite important as well, because it starts at 400 with a 50 hertz frequency, with the including 230 volts ticked. So what we're saying there is we've got 3-phase on site, we've also got single phase 230 on site, and they're both available to be used. So that means we've got a bigger pot of products to choose from. Because obviously larger cooling units use 3-phase, smaller cooling units and fans and things might use single phase. But this customer only has 230 on site, so what we do is we hover over this box and this little selector comes up with all the different voltages. So we're going to click 230 and say, no, all we have on site is 230. So obviously this box is gone now because 230 is in here, and that's told Therm software in the background, don't look at anything that doesn't work with 230, and it's narrowed it down for us, so that's nice. Okay, when we're happy with this screen, when we've put all the information in there and we're happy, we just click our arrow to take us to the next tab. Right, now we are going to add the information about the enclosure that we are using. So it defaults to the new VX25 enclosure system, which is obviously the brand new one, or the forefront of technology for Rittal and what we offer. However, if you're using something else that's smaller, or maybe you're still using, I don't know, TS8 or something like that, if you click that drop down, it gives you a long list of all the other types of products that we offer. It's got, hygienic design in there. It's got the KX, AX, all those sort of things. TSIT for IT enclosure systems, although IT cooling is its own thing, but you can sort of do some calcs in here on that. So we're going to stick with VX25. However, one question before it's even asked, I will take questions at the end, but one question we get a lot is, this is a weird and wonderful size. It's not a Rittal panel, or it's a very old panel. That's not a standard size. So if you've got something that's weird and wonderful, what you can do is, if you scroll right to the top, there is one called SO, Special Sizes. And if you click that one, what happens is it allows you, then it opens up this width, height box, and it allows you to manually type in there whatever size you want. That'd be quite a big panel, but yeah, it allows you to type in whichever width, height and depth you've got to fit your on-site real panel. So if you're retrofitting, that's probably what you would do, unless it's an actual Rittal product with a part number. Now then, we're going to go back and use a VX25. So I'll just click back on VX25, and now when I click this second drop down where it says please select, it gives me all the standard part numbers with the dimensions. Now, if we've got anybody out there who doesn't do their measuring in this orientation, width, height, and depth, if you go to the drop down at the top and change the language to American, it actually flips these dimensions to suit the American way. So if you're working for an American customer or a project, you can flip these around if it just makes it easy for you to read, because obviously they do dates differently to us as well in the UK. Right, okay, so what we're going to do is we're going to choose this one here. So we're going to choose meter wide, 2 meters high, 600 deep. Just click on and pop it in there for us. The next thing we need to choose on this screen is the position of the panel, the enclosure, when it's on site. Now, there's 7 different options to choose from. The reason this is important is because what this software is really doing is it's saying, right, I'll look at the whole surface area of steel that I've got to work with, and that heat can be lost through. Because obviously, if it's really hot inside the enclosure and it's colder in the ambient temperature or in the ambient environment, the heat from within will sort of leak out and go into the ambient environment and do some natural cooling. So the more panels, the more sort of sides, front doors, back doors that we've got open to the ambient air, the higher level of cooling we've got to start with. So on the flip side of that, say for example you were building a small cabinet into a machine where all it could see, all you could physically see was the front door, you would choose number 7, because then that would be an enclosure within a suite. So that means, if you can see the little diagram on the screen, that means its left-hand side, its right-hand side, its rear, and its roof are all covered by steel or some sort of wall. So that means the only place where heat could dissipate would be through the door, and therefore you would probably need a larger cooling unit to help you get that temperature down. That's quite an oddball one. We don't get that very often. Normally what we tend to have is enclosures on their own, wall mounted or maybe freestanding, because they're sort of in the center of a room, etc., in like an industrial factory. Or we will have them where they are in a suite, or also known as bayed together. So as you can see from these little diagrams, it might be the first one in a suite where it's starting a row of enclosures that are connected together, or it might be sandwiched between 2 other enclosures, but we'll come back to that later on. So what we'll do for this one is we'll just choose single enclosure for wall mounting. So the rear, no heat can dissipate from the rear because it's up against the wall, but all the other sides are free. So we click Save Enclosure, and it takes us to the next screen. And the next screen, as soon as you go onto it, you get a little message at the top, and it says, whoa, hang on. Is there any heat being lost inside this enclosure? Now, what that means is the word heat loss. It basically means, are the drives or the transformers or the PLCs in there generating any sort of heat? And the answer 9 times out of 10 is going to be yes, because nothing is 100% efficient. Now, rule of thumb could be, and this is totally a rule of thumb, it's not scientific, is that 3% of a drive's total power is lost as heat. However, what I would heavily recommend is you speak with the manufacturer and get actual heat loss figures. A lot of those now are included in their installation manuals or their technical booklets, and will give you, an actual figure, and it'll say this 10 kilowatt drive loses 400 watts of heat. And obviously what you then need to do is add all those watts up and put them in the software so it knows how much heat we've got to handle. So it's asked me, do I want to add any heat loss to this enclosure? And my answer is okay. And it will open up this little pop-up box. Okay, so we've got 3 ways that we can tell it about our heat loss. The first one is just a figure. So if you know for a fact, because you've used ePlan, for example, or you've got a design, or you know all this equipment, and you know it exactly loses 500 watts, you can just type it in there. Remember, that's in watts, not kilowatts. So 5 kilowatts would be 5,000 watts. 500 watts is half of a kilowatt, depending on how you wish to speak and reference it. Now, there's 2 other tabs in here that we can use. This second one, is measured temperature. So the measured temperature, excuse me, is where you've had sensors, temperature sensors on site, and you've witnessed or got a graph or something of actual temperatures that have been measured on site. So what you can do is you can say, right, there's obviously some default figures in there. So this example is saying the ambient temperature was 20 degrees Celsius but inside the cabinet was 50 degrees Celsius. And if I click accept on that, the algorithm or the calculation and equation inside this software will think, right, based on those two numbers, there are this many watts being lost inside of the enclosure. So that's another way you can put it in. If you don't know the actual figure, you could take some temperature measurements. And again, that is something, as Rittal, if you need that sort of way, if it's an old panel and you don't know what's inside, we can help you with that. We can come and do those measurements on site for you as a way of getting some, tangible evidence that you can work with. The next one is the device list. So the device list is basically a very sort of rough list of sort of manufacturers such as ABB, Eaton, Buzz Bars are in there from Rittal, Rockwell, things like that. And you can click on these and then look in these other drop downs here, like component group. Component group. So you might want to click drives, and then you can click the device drop down box. And what it will do is it will pull up all the Rockwell part numbers that we have in here. And then so if you think, 22AA4P59104, wow, we've got one of those in there. I'll click that. You've chosen it. And then what you can do is you can choose the simultaneity factor and the quantity. And then what it will do is it's automatically in the Therm software, it's got a value for how much heat loss is lost by this Rockwell part, which is 50 watts. So again, if you put in 5 in there, you can increase the number with the little buttons and say there's 5. Once you're happy with this information here, you click add device and it pops it into this drop down box here. And then it will say Rockwell automation drive, blah, 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 quantity 5, total heat loss is, 50 times 5. And then you click accept. So there's 3 ways there. You can either build up a literal list of each drive, each part number. And if you're doing this a lot as well, you can go into the options of Therm and put your own drives in there. So if you use the same PLC on every panel you build, but it's not in this little list that's on here, you can put it in there if you know that information. Okay, so for the speed of this demonstration, I'm going to go back to the direct input and just put a normal just a figure in there, because when I spoke with Joe Bloggs this morning for this project, he gave me an actual figure which was 500 watts. So I'll accept that, and it will now take us back to the screen we were on before, which was enclosure selection. So the only difference we have is in this heat loss section here, it's put in the 500 watts that I input. It's got the model number, it's got the dimensions of the enclosure, the position, which was number 2, which was against a wall on its own. And then you've got 3 actions you can do in here. You could either delete it completely if you've done it wrong and you want to start again with the X. You can click the pencil to modify the enclosure. So maybe it's not 600 deep, maybe it's 800 deep. So you click the pencil and it will take you back to the previous selection screen. Or if that heat loss is wrong or it's increased, click this pencil under heat loss and you can make it larger or smaller. So really quick. Obviously I'm going through it relatively slow, but once you know how to use this, you can literally just click, 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 and you can be going through it quite quickly and get an answer. Okay, so we're happy with this enclosure. Now we're going to go on to the actual calculation. So we click the right arrow again in the bottom right hand corner, and that will take us to the next tab, which is calculation. In the calculation tab, this is where we now start to select the actual cooling product that's going to do the job for us. This is really cool, actually. It gives you some, pardon the pun, and it gives you some interesting bit of information that you can use for your own benefit, or maybe feedback to your customer if you've got another end user you're working for. So as I mentioned before, it's looked at the dimensions of the cabinet, and it's looked at that and calculated the total surface area that it's working with, which in this instance is 5.8 meters squared. It's saying that inside that cabinet there is installed 500 watts of heat loss. It's saying the dissipation of watts via the surface of the cabinet. So this 5.8 meters squared is dissipating 319 watts of heat. So that's a positive thing. Because the ambient temperature is colder than the internal temperature, this cabinet is losing watts, it's losing heat. So that means we don't need as much cooling. So that's why these temperature figures are so important. So although we've got 500 watts inside, because 319 is being lost by just natural dissipation through the steel, now we only have to put in 181 watts worth of cooling capacity to maintain that 35 degrees C inside the cabinet. If we do nothing, if we don't do any cooling, on average, the temperature inside that enclosure is going to be 41 degrees C. Okay, so that's only 6 degrees higher than the set point we wish to maintain. But believe you me, 6 degrees is making a big difference and will affect the lifespan of your equipment. And this is quite a tame example I'm giving you here. A lot of the time, I've seen them here where it's over 100 degrees inside, and believe, again, I go on sites all the time. You're opening those cabinet doors, or an engineer showing you inside a cabinet, and you get a waft of blindingly hot air coming out because there's so much gear crammed inside a small enclosure with no climate control, and that these temperatures can escalate, and that is it's no good for your equipment, believe me. So right, we're going to collect, we're going to select a piece of equipment now. Because the ambient is so low and is lower than the internal, all of these options are available to us. They've all got little green pluses, so we're living the dream here. We're a kid in a candy store. We can choose what we want. So we're going to specify a fan and use that difference in ambient air temperature to our advantage. So I've clicked the little plus next to fan, and it's taken us into the select a fan screen. And there's a few little bits of information that are interesting in here as well. So what it's calculated for us is, the first thing, if we need to maintain 35 inside the cabinet, we need 62 meters cubed per hour as a minimum to get enough cooling and enough air through there to wick away all of that heat. Okay, we don't need a cooling unit. We don't need a refrigerant circuit because the ambient air is acceptable. However, climate control is definitely necessary. Another thing is it defaults at this sea level, and if you click that, it changes. So again, and I've done this, if you're doing a project for Peru or somewhere exceedingly high, that does make a difference because the thinner air changes the performance of cooling equipment. So it's worth asking the question, where is the final destination for this product? Because it does make a difference, believe me. So it'll default to this standard above sea level figure, but there's plenty of others to choose from. Okay, so the next thing you're going to want is, you've got all your suggestions down the left-hand side, and it's a myriad of different choices for you to make. And it starts off with the lowest power, which is a combination of 2 fans and 2 filters. So the filters are just square cutouts with grills that allow hot air to escape. And obviously the fans actually are drawing cold air into that enclosure. And those two in combination together will give you 86 meters cubed per hour. And we only need 62. So we're living the dream straight off the bat. So that's perfect. We've got what we need. Now, it's totally up to you. You can choose any option you want. You might want to go much bigger because eventually you're going to actually expand this panel and there's going to be more equipment in there. If so, I would recommend doing the calculation as if it was already fully populated and really put that belt and braces on there, make sure there's enough cooling in place. But I don't know, just for the sake of fun, I'm going to choose this one here, which is 87. Now, nice little aside here is, if these are all wall mounted, so these can go on the side walls or the front wall of your enclosure. However, if you wanted a roof mounted, you just click this button here and it brings up a list below of roof mounted options, which are all here, look. So then you'd have a roof mounted fan with a filter, The filter would go in the door or the side wall, and the roof-mounted fan, funnily enough, sits on the roof. So we'll just get rid of that. And also, if you need EMC, which is obviously a separate string of products that we sell, just click this EMC button and it will add them into this list. The final thing before we leave this page is there are two little magnifying glasses here. Now, this first magnifying glass, this is called schematic, and what that's going to show you is basically how the air flows. So again, this is what I was describing before. You have your fan at the bottom sucking that cold air in constantly. It runs over the equipment inside, and then the filter is an open grate. I say open, but obviously it's covered to protect fingers, etc. And the hot air, as it warms up through natural convection, escapes through the top, and the circuit begins again. So that's just there to, in your mind, if you don't know what it does, you can quickly have a look and think, that's what it does. Now, that second button is quite interesting as well, because obviously these part numbers, even I don't have all these part numbers memorized. And, you know, you guys are much more committed than me if you do, or you're much smarter than me. But if you want to know maybe about the size or what dimensions this fan unit is, or this filter, click this technical information magnifying glass, and we'll give that a click, and it pops up a really handy, quick summary of all the data that you can find on the web page, the color, the IP rating, its operating temperature range, dimensions. So it's 204 millimeters square. Its operating voltage. Obviously, we already know that because it's going to be 230 volts because we specified that right at the start of this presentation. If you want more information, click this little pink guy here, and it opens up a tab to this product on the Rittal website. So if you want to buy it through the web shop, not an issue. Click that tab, take you to the page. You can add it to your basket. Bob's your uncle. Now then, so we're going to go back and just close that technical information because we've had a look and we're really happy with that one now. So we're going to choose it again and we're going to get out of here. So we're going to accept that we want that fan, and it will take us back to the previous screen that we were on, which was the calculation screen. Right then, so now you can see fan has a little pencil. The pencil means you can edit, so you can go back in there and change that if you like, if you don't like it, or you need a bigger one or a smaller one. Also, you can press this little minus button here, and that will just delete it instantly. So again, if you've made a change or something's happened, you're going back into this after 3 weeks because you've changed something, just click minus, it'll whip it out of there, and you can start the whole fun again. Now, as you can see, the rest of them are also still available. If you wish, if your customer or you haven't decided whether you want a fan, whether you want an air-to-air heat exchanger, whether you want a climate-controlled door, you can spec more than one in here if you wish. And then you've got one, as you'll see later on, you've got one PDF document that shows you all the options you could choose from, and then you can maybe get a quote for all of them and decide later on which one's the right one for you. That's totally up to you. Okay, so the problem is I've just had an email from Joe Bloggs, and he's actually changed the specification of this project now, as customers are willing to do at quite a rapid rate, which is not a problem. We can manage it, we can deal with it. So what he said is now they've actually got it wrong. The ambient temperature is not actually 25 degrees anymore, it's actually 40. So I'm just going to change that number to 40 and click, and it's going to go whoop, and oh dear, all of a sudden these two now, these ones that use ambient air configuration, not possible because it's hotter in the ambient than it is in our internal. So we cannot use ambient air to cool us, because that would be like opening the window on a hot day and expecting to get colder inside. It's not going to work. So what we need now is a cooling unit, something with a refrigerant circuit, okay? So we're going to do the same process again, but we're now going to add a cooling unit. So we're going to click on the little green plus next to cooling unit, and it's going to take us into a very similar page all looks very similar, just a few more options in here now for us to play about with. So it defaults as a wall-mounted cooling unit, so that can be on the left wall, right wall, or the front door. You can click roof if you wish, and it will bring up options for, you guessed it, roof-mounted cooling units. So they'll be sat there at the bottom. If you only want stainless steel because your cabinet is stainless steel, obviously click that one. If you need a rated NEMA 4X or NEMA 3R/4, have specific products that suit that range. For anybody who doesn't know, NEMA is it's not exactly the same, but it's on the same vein as IP rating, and it's used more across the pond over in the Americas. So if it's something of interest, you can just click these two buttons here and filter out. So all you get is NEMA rated products. That's totally up to you. The information down this right hand side here is your minimum level of IP ratings that you're going to require on the cabinet, because obviously we don't want air leaking into the cabinet because you've got an all wobbly cabinet on side, because the cooling unit won't do its job correctly. Is a cooling unit required? Yes, it is. What level of cooling do we require? Well, because that ambient temperature has climbed so much, we now need, at worst case scenarios, just over 650 watts worth of cooling. So the power rating that we require obviously has climbed. So then it's exactly the same as we just did before, which is we can, click on the one we fancy. You've got Blue E, you've got the Blue E Plus models, and the power starts at the lowest and then climbs. You've also got another magnifying glass, which is a very interesting one for you. It's the performance diagram. Now, this performance diagram is very useful, and it's a bit of an unknown secret that I would recommend you start to use more often. It's basically the performance diagram of this unit, because like anything in life, like a car, for example, if a car starts to overheat or has to operate in hotter temperatures, it won't be able to perform as effectively. A climate control unit is exactly the same. So as you can see from this little diagram here, across the bottom axis, we've got the ambient temperature, and up the side, we've got how much cooling power we have available. And then these diagonal lines are showing you the internal temperature we're trying to maintain inside of the enclosure. So what the Therm software does for us automatically is it goes, right, he's said 40 degrees C, so I'll pull a line up this way, and he's said 35 degrees C inside. Oop, that's where these two collide. Therefore, the maximum cooling that this cooling unit can provide at worst case scenario is just under 1.5 kilowatts. Now then, this is why it's important for these temperatures, because you get some customers who over-egg it, and they'll say, oh, it gets to 70 degrees C. If you say that, that's fine, but you're going right up here, and there's a lot of issues that are involved with such high temperatures. Because look, say for example, the customer over-egged it and said, oh, it gets to 50 degrees. If I pull this up, and we go to 35 degrees C line here, and pull across, look how, obviously it's not exact, but you're much closer to 1 kilowatt, so you're losing cooling all the time. So having those temperatures right and estimating correctly is important. On the flip side, if the customer wants to use a cooling unit, but it's colder in the ambient environment, but for some reason they still want to use cooling units because maybe it's very dirty in that environment and fans and filters wouldn't cut it, the lower the ambient temperature gets, the cooling unit actually increases in rating. So if it was 25 degrees Celsius, but 35 degrees inside the enclosure, the cooling unit's nearly hitting 2 kilowatts. So the flip is also true. It can get better, it can get worse, all dependent on those ambient environments. So we'll close out of that, but that's a nice little bit of information there for you. So if you ever want to just have a quick look and see the capabilities of the product that you're looking at, you can access it there. It's also available on every product page for every cooling unit. If you go onto the product page of a cooling unit, there's a performance diagram button just next to the picture at the top. Click it, you will get that same performance graph where you can manually manipulate the temperatures that you see, and it will give you a figure. So if you just want a ballpark figure straight off the top of your head, go onto the website and you can get it. Right then, so now we're going to choose a cooling unit. So we're just going to randomly choose this one here, 1037, bit of belt and braces. You know, we never know what's going to happen on site. People like to sneak extra equipment inside an enclosure, so we'll pop another one in, you know, we'll pop a larger one on there, the budget. So we'll add that blue cooling unit. So we'll just wait for that to move to the next screen. Right, so the next thing is cold temperatures. Cold temperatures are as damaging as hot temperatures. If you have a panel outside with a pump, for example, car analogy coming again, it's much like your car outside on a cold day. It needs to warm up because those oils inside your compressor, you know, they get more viscous, they're harder to push, pumps are working harder. So making sure it doesn't get too cold inside an enclosure is just, you know, something that's not considered as often, but should be on your mind whenever you're specifying a panel and you think it's going to get cold. Because, I mean, think about it. A factory gets freezing cold over a weekend when everything's shut down and there's nobody there, especially in the middle of winter. So keep it in your mind and make sure you protect from the cold as much as you do from the heat. So that's why we go into heaters. So I've just clicked the little heater plus button and we've gone into this separate heater screen, if you like. And it's very simple. You just do the same again. You're going to say, what's the lowest ambient temperature we're ever going to see in this factory in the middle of winter? It's in Scotland. It's freezing cold. It's going to be 5 degrees. Okay. What's the minimum temperature we want inside the panel? Well, we want it to maintain a floor of 10 degrees or above. So what that's saying from these two figures, it's saying to us that we need a minimum of 160 watts worth of heating. And it's giving us heaters here, which will give that amount of power. Now, there's another little button here that basically, if you're going to site it outdoors, they recommend on the software, it recommends clicking this button, because what happens then is it doubles this figure as like a belt and braces, so you've got a more powerful unit. Because when you're outside, it's very, you know, it's very unreliable. It can get freezing cold. Issues can come. It could be, you know, it could be a cold snap that you've not expected, and there's icicles dropping off this enclosure. So you need to make sure that the heaters are man enough for the job. And as well, it does recommend here. This bit of text here says that when you're using an enclosure outside, you should probably have a second heater. That second heater is there as a redundancy piece of kit, which if the first one breaks because they're having to work so hard, this one will kick in, or they will work together. So again, just keep that in mind. You know, if you've got a specific job, maybe that's going somewhere very, very cold, speak to us and we can give you some good advice on that. So it's exactly the same as what we did with the fan and the cooling unit. You just click the one that you want, you know, you choose the power that you need. You've got the same schematic there and technical information that you had on the other ones. Just click on those little magnifying glasses and you just click accept and choose your heater. It takes you back to that calculation screen where we choose our cooling or heating. And as you can see now, we've got two boxes populated. We've got our heater, we've got Blue E cooling unit. Right, so then the next job is accessories. So we click the little right-hand arrow to take us to the next tab. And now what you will see when it loads up is a list of suitable accessories for the cooling or heating products that we have chosen. So as you can see, that's the main article number of the cooler or the heater that we have chosen. And these are the relative accessories that link to it. So the main things are things like thermostats, which you're going to need to run a heater, or you might want if you're running a fan and filter. There's also, you know, things like spare filter mats or blanking covers, hose-proof hoods. There's all sorts in there. But basically, dependent on what you choose on the previous screen, it will change this list to suit. If there's something in there that you want, just click in the box, click a number, and then click off, and it will reload the screen. That box is now grayed out and it's got your number 1. If you don't want it, just click in the box again and delete it, and it will take it out for you. Simple as that. So that's your accessory screen. You can, choose to your heart's content and whatever suits your project. Next box, we take it to the summary, which is the end of the Therm calculation. So we'll just click that right button and it'll take us onto that summary screen. So the summary screen, as you can imagine from the word summary, literally just shows us everything that we've inputted. Now, it's not massively useful in this orientation because it's just on a screen and it's a bit squished. So the best thing for you to do, and something that's more customer facing and easy on the eye, is you've got all these buttons at the bottom and ways to export. So this one over here is obviously print it, so you can print all this out. There is XML files, HTML files, TXT files, or the one that I use constantly is the PDF. It will create a PDF on the fly for you, which you can then obviously save in your files, or you can print it out or email it to a customer, because obviously normally I'm doing them for customers or for our sales team. So I will, make a PDF, open it up, and then save it in my file, so I've got a record of it, when somebody asks about it 2 years later, and then, send it on to the customer. So that's now downloaded, and it's just loading up in a separate tab, and this is what it looks like. So this is all the information we put in: assembly line 1, ABC manufacturing, Joe Blogs, etc., etc. It's got the parameters for the temperature, what enclosure we chose, where it's located, and then it shows you, what temperature it was without climate control, how much heat loss is inside the enclosure, all that good stuff, how much is going to be lost across the surface. And then if you go onto the second screen, it replicates what we saw in the actual Therm software, which is we've chosen number 3 cooling units, we've chosen that cooling unit, and we've chosen that heater based on these temperature parameters. And then we've also chosen as an accessory this thermostat. So that now you can, go to the top and save it or print it, do whatever you want with it, and there you've got bang, something you can give to your customer in your project pack. We did a Therm calculation, and this is what this is what we use to choose our cooling unit. The worst thing is when I get a call from a customer saying, "Oh, the cooling's gone wrong on site," and my first question is, "Well, did you do a Therm calc?" And they go, and then they're thinking, "Oh my God, I'm not sure if Big Dave did it in the office. Did Mike do it?" And they've got no answer to that question. So make sure you keep a copy, and you're covering your own back. Now then, as there's extra features in here that I haven't covered in the example that I've just given you, so we're going to carry on because we've had another call from Joe Blogs, and he's actually now completely changed the project, which again happens quite often. That's totally fine. We can roll with it. So he's now saying that it's actually 2 cabinets bayed together, but they have a wall separating them, and they have heat loss separate inside each cab. So we're going to go back and do that. So we're going to go all the way back to the start and just quickly bay some cabinets together so I can show you how you do that. So what we need to do is go back to enclosure selection, because obviously now we've got another enclosure to play with. So this first enclosure that we already put on there is correct. However, there's one mistake now. Its position before was number 2, which is a single enclosure for wall mounting. It's no longer a single enclosure, so we need to just dive in there and click that little pencil, which is going to edit the existing enclosure. But we need to change its position to tell the software that it's now part of a suite. So instead of number 2, it's going to be probably either a number 3, which is first or last enclosure but freestanding, so that means it's not against a wall, or number 4, first or last enclosure in a suite for wall mounting. Now, because it's only a 2 enclosure suite, it's going to be number 4. If there was more than 2 enclosures in this suite, the first one would be number 4, The second one would be number 6, and then the last one would go back and be number 4 again. Because remember, if you think about number 4 as your bookends on your left and your right, and the one in the middle, as per the diagram, is sandwiched in between. So always check these and make sure you're putting them in correctly, because otherwise you'll wonder why your calc's not working. It's normally because this isn't right. Okay, so we've chosen number 4, and we're going to just save that enclosure, and then we're going to add another enclosure in. So we're back to this screen, and we need to use this button, which funnily enough is add enclosure. There are a few questions coming through on the screen. What I'm going to do is, just to not break the flow, I'm going to answer them all at the end, if that's okay with everybody. Okay, so we're going to add another enclosure now. For the sake of argument, it's going to be exactly the same enclosure, so we don't have any issues on depth or height, so we can bear them together. So we've chosen that one, and we're going to say it's the first or last enclosure in the suite for wall mounting. So we'll save that, and now it will take us back to the screen, and we will get a question of, do we want to add any heat loss inside the enclosure? And yes, we do. So we're going to click OK, and it's going to take us back through the screens we've already seen, which is the heat loss screen. So I'm just going to put 1 kilowatt in here. So that's 1,000 watts, and click accept. And then now what we're doing is we're going to just sort of rinse and repeat what we've already done. But just a couple of extra features that I want to show you to make sure you just do it correctly. Now we've added another enclosure, it's come up with a new button for us to play with, which is the baying button. So if we click this button, it will give me a nice visual representation of what I'm trying to explain. So this baying section or baying screen has now our 2 enclosures, position 1 and position 2. If you want to get really fancy and it's a really long panel, you can actually type the specific names in here. So if this was the PLC panel and that one was the, I don't know, the variable speed drive panel, you can type in here and name them anything you want and get really detailed, which is nice. But what you can see here is there is a solid line between these 2 enclosures. So that means there is a dividing wall between them. If this was 2 enclosures which were bayed together with no wall in between, thus making a very large 1 enclosure, you click this little plus here. And what that does is it just combines the meters squared area of these 2 and treats it as 1 massive panel. Okay? So if you click that, it would change that to a dotted line. We'll do that in a minute, actually, for fun. But for now, we will keep them as 2 separate enclosures bayed together. So we go back to the calculation screen where we start to choose cooling. And as you can see now, we've got more information here as well. We've got our 2 enclosures. But as you can see, the first one is highlighted. So now we have to choose which one we want to spec cooling for. So this first one, the one on the left-hand side, if you like, with the 500 watts inside. So we will just quickly go in there and specify a cooling unit for it. So we'll click just that bluey there and just click accept. And now he has a cooling unit. However, we've still got more heat that we have to deal with in this one. So we just double click. It will reload the page. And as you can see now, we're working on the panel with 1,000 watts inside, and there is no cooling specified, and it's highlighted it in yellow. So you just need to make sure that you spec for both. So we'll just quickly pop the cooling unit in there, no problem at all. And then we then know that both panels have got enough cooling inside to do the job and keep the set point down. So we'll just load that screen up now. And then we will choose a bluey plus cooling unit. We will click accept. It will take us back to the calculation screen. So now if we click between these 2, they both have cooling units. And as you can see, this one, because it had a kilowatt inside, it would have got up to roughly 74 degrees inside, and that's going to really damage your equipment. So again, just proves my point that, the temperature can get away from you if you don't use cooling. Okay, then what you would do is, as normal, you would click through into the accessories tab, choose the accessories that you want for the cooling units you've chosen or the heaters that you've chosen, go back to your summary page, export it as a PDF or a TXT file, whatever, pick your poison, and then you can send that on to your customer or save it into your files. The final way to do things is what I just referenced, which is we're going to go back and we're going to take out that separate plate, so it then treats that enclosure as one large enclosure. So we're going to go back to enclosure selection, and we're going to click the baying button. It's then going to take us into the baying section. And now if I click the magic green plus, it is going to sew those two together and get rid of that panel. So as I mentioned, that is now dotted, which means there is no separate panel inside, creating two smaller enclosures. And the way you can prove that and check that it's done it is, look, it has combined the two surface areas together, and it has also combined the 500 watts and the 1000 watts together to say that inside this now one large enclosure is 1.5 kilowatts worth of heat. So we are now treating it as one big lump of heat. Okay, so then we just go back to calculation, and it will give you a warning, because obviously before we'd specified products that now won't work. So it will get upset and tell you. So all you need to do is you just need to delete out the cooling units that you chose before. Just make sure that they're all out of there, and then we can specify again. And just be warned as well, don't get worried if you look at the first enclosure and it starts to say zeros. The reason it says zeros is because now it's treating it as one large enclosure. So if we click on that bottom enclosure, it's actually treating it like it's all in this panel, spread across the two. So don't worry about it, just specify in this one. So because it's funny actually, look, because although we've got more heat in there, strictly speaking, we've got 1.5 kilowatts, the average temperature is actually reduced because it's spread over a larger surface area. So it's funny how that happens sometimes. You might not get the result you expect because now we actually need less, roughly, less cooling. So we'll just specify a cooling unit in there, and then this calculation is done. So it needs 1793 watts, or just under 1.8 kilowatts. So we will choose the Bluey Plus just because that's the most energy efficient product, and we will click accept. And then from there, it's just a case of rinse and repeat what I showed you about, which was adding the accessories, doing the summary, and then exporting that as a PDF. So from the webinar point of view, that's the demonstration I wanted to show you. I just wanted to show you the three main ways that you can use the software for a single enclosure, two enclosures that are bayed together, and then two enclosures or 3 or 4 or 5 enclosures that are bayed together without panels separating them internally. The principle is very, very similar regardless, but they're the key points that you need to know. So what I'm going to say now is, I don't know if anybody's seen it, but there's a handout section on the GoToWebinar, and in there I have included a PDF which is called Blank Therm Questionnaire. I recommend everybody downloads it. If you don't download it, we'll get one sent to you on email, or we'll put a link to it on an e-blast or something like that to everybody that's attended. That small PDF document is basically just a single page with all the bits of information that you need to perform the therm calculation like I just did. So the reason that's important is if your customer's like, oh, we need cooling on a site, they're not experts in cooling. Frankly, you're not experts in cooling. We don't expect you to be. You make what you make. We make the cooling. So this is just a little helpful sheet that has the main things you need on there, such as ambient temperature, heat loss, voltage, all those good things. It's a quick cheat sheet that you can fill out, and you can either do the therm calculation yourself, or if you need any help, you can send that therm questionnaire to your Rittal ASM, and they can help you out as well and do the therm calculation. So that's the end of the presentation. So I just wanted to, I'll put my details up again. So my name is Carl Lysett. I'm the Climate Control Product Manager. Again, if anybody has any questions, send me an email. Get a dive on that. Get a dive on that LinkedIn. You know, get on my LinkedIn. Get on Rittal UK's LinkedIn. We're putting a lot of information on there. There's a lot of articles at the moment going out. We do videos. We're doing a lot more webinars on all the different Rittal products. So you know, get on there, follow the content, and it'll hopefully help you. So right, let me now have a look at the questions that we've had, and we can answer them for everybody's benefit. So I think that, you know, when we've done the webinars in the past, the questions normally help everybody. So let me have a look. So, is there a way to integrate this software with ePlan? That's a very good question, and the answer is yes. ePlan, if you use it, actually, you can go, while you're working inside ePlan and designing your panel, you can, sorry, I'm just reading another question where somebody's asked another ePlan question. So yeah, when you're working in ePlan and you spec a cooling unit, it automatically takes you into the Therm software. You do your Therm calculation as you've just seen, and then once you've specified the cooling unit, it pulls you back into the ePlan software, and you can do a 3D representation of the cooling unit that you've then specified. So it's a really powerful tool. Right, let's have a look. Let's have a look through the questions. Is it possible to select a fan that is unsuitably sized for the enclosure? No, it is not. The software is quite hard and fast that it will only allow you to choose solutions that it deems will be correct and will work. However, if for some weird reason you want to specify something that Therm won't let you specify, we have all the performance curves and performance figures for our fans, etc. So if you need help on a special project, and you know, it happens from time to time, speak with your local Rittal ASM and we can help you on a sort of project by project basis. Okay, next one. Yeah, I've had this question a couple of times and it is a very good question. If you bay a number of enclosures together without an internal divider, can you just use the special sizes and treat it all as one large enclosure? The answer is yes and no. You can, of course you can. You can make that panel any size you want, weird and wonderful. The reason why I wouldn't recommend it is because there's a little bit of genius inside choosing the Rittal panels, and that reason is a Rittal panel obviously works on a frame system. When you choose an actual part number and bear them all together, although it takes a little bit longer and a few more clicks, the software then takes into account the areas that you cannot foul, because obviously if you foul the frame in any way, you won't be able to fit your cooling unit or your fan. So it will automatically take that into account if you choose VX25. If you don't choose VX25 or a Rittal product and just use a special size, just make sure that the dimensions that you're working with on the enclosure cooling unit and the enclosure mean it will fit without fouling anything. So the answer is yes, but also no. So it's yes, you can do it, but make sure you check and double check before you get on site and think, oh God, it won't fit. Right, let's have a look. So yeah, somebody's asked a very similar question where they've said, you know, if they've got loads of a similar size bay together, could they just make it one big one? And obviously I would say refer to the last answer, which is sort of yes, but no. And then the final question, is the software free? Absolutely, it's free. It's on the website. You can you can just go on the website as I showed right at the start, go under the support tab and download the Therm software either for offline use or for online use in your browser, whatever your preference is. Another question somebody said is, if reactors are installed in side panels, how to select cooling fans and sizes? I'm sorry, I don't know what you mean by reactors. Finally, is there any other questions? Let's have a look. Somebody's saying as well, is it better to work on the panel as a full width, or maybe break it down into sections? My point would be treat it as one big suite. Don't treat them as separates, because obviously when they're all bared together and treated as a suite, it works out how the heat is dissipated when it's actually sandwiched up against another enclosure. Okay, and there's another question from Nigel. Does Thermcalc include door fans used in conjunction with roof-mounted exhaust filters, model without an integral fan? So what you're meaning is air vents, but then putting fans on the door. You can do that, yes. I'm not actually, it's a great question and something we maybe need to look at offline, because I don't think you can specify on the software a roof vent with fans in the door. That would be something we would have to do using the performance diagrams and the performance curves. But the good thing for you, what you could do is you could use Therm to get you the airflow figure that you require, and then we could just spec the right size of fan and air vent to allow adequate airflow and thus adequate cooling. Okay, so I think that is everything. So all I would say is, if anybody has any more questions or anything specific to a project, please drop me an email and I'll happily help you out on that. And apologies for the slow internet on my side at the start. Please don't think that's Therm, because obviously it just works on the browser, and typically mine started to play up as we started to present to everybody. We've got a lot of people attended today, so again, really want to thank you very much for coming on board. Check out, like I said, we've got a series. We're doing webinar Wednesdays every Wednesday at the moment. For everybody now that's maybe working from home, I've got some more time to increase their skills, etc. So, thank you all for coming out today. Thanks for attending, and see you soon.